Everyone. So let's talk about back-end development, but we're going to go way beyond just writing code for APIs. We're going to look at the powerful, often invisible systems that really make modern applications work, the stuff that turns a simple project into a robust, scalable piece of software.
It's so easy to fall into the trap of thinking that backend is just about building some endpoints and shooting back some JSON. But honestly, if you're serious about building something solid, something that can actually grow, the real magic, the real engineering is in what happens behind the scenes.
All right, so here's how we're going to break this down. Think of it as a journey. First, we'll talk about securing the gates. Then, we'll dive into how to properly manage our data. After that, we'll focus on making everything feel lightning fast. And finally, we'll look at what it takes to scale for massive success.
Okay, part 1, securing the gates. First things first, right? We have to talk security. Before we even think about cool features, we need to make absolutely sure our application and its users are protected from the get-go. Now, this is one of those concepts that trips up so many developers. Authentication versus authorization. The easiest way to think about it is this. Authentication is you showing your ID to get into a club. It's just proving you are who you say you are. Authorization, on the other hand, is about whether you have access to the VIP section once you're inside. They are two totally different things, and mixing them up is a classic recipe for security holes.
Next up is your application's bouncer, its protective shield, rate limiting. This is all about controlling the chaos. It's a simple rule that stops any single user, or more likely a bot, from just hammering your system with a crazy number of requests in a short amount of time.
And why is that bouncer so crucial? Well, for one, it's your first line of defense against abuse, like those nasty denial of service attacks that try to take you offline. It also means one power user can't just suck up all your server's resources, leaving nothing for anyone else. Ultimately, it's about ensuring fairness and keeping the lights on for everybody.
All right, with security covered, let's move on to the absolute heart of any application, the data. How we store it, how we get to it, and how we keep it safe and consistent. This stuff is absolutely fundamental.
So, picture this. It's a problem every single developer runs into eventually. Your app is a success, your database is growing, and suddenly, everything is slow. Simple lookups are taking forever. It feels like you're being forced to read an entire encyclopedia from cover to cover just to find a single sentence. There has to be a better way, right?
And there is. The answer is a database index. Without one, your database is doing exactly what we just described, a full table scan, looking at every single row. It's slow and painful. But with an index, it's like flipping to the index at the back of that encyclopedia. It tells you exactly which page to go to, letting you jump right to the data you need. It's a total game changer for speed.
But what about keeping data consistent, especially when you have to do multiple things at once? Take a money transfer. You've got 2 steps. Take money out of account A and put it into account B. You absolutely cannot have one of those steps succeed and the other one fail. That's where a transaction comes in. It wraps both operations into a single package, a single promise. Either both things happen or neither of them do. All or nothing.
And that all or nothing promise is backed up by these 4 properties, famously known as ACID. A is for atomicity, that's the all or nothing part. C is for consistency, which ensures your data rules are never broken. I is for isolation, which is super important. It means multiple transactions happening at the same time can't corrupt each other. And finally, D is for durability. Once a transaction is done, it's done for good. It survives a crash, a power outage, anything. Together, they are the bedrock of reliable data.
Okay, so our system is secure and our data is safe. What's next? Let's make it fast. We want users to feel like our application is responsive and instantaneous. Performance is key.
One of the biggest and honestly easiest performance wins you can get is caching. It's such a simple idea. Instead of hitting your database over and over again for the same piece of data, you just save the results in a really fast place, like in memory. The next time someone asks for it, bam, you give it to them instantly. No database needed.
But what about jobs that are just naturally slow, like processing a huge video file or sending out thousands of emails? You can't just make the user sit there staring at a loading spinner. So instead, you use a message queue. Your API gets the request, immediately puts the job onto a to-do list, the queue, and tells the user, got it. Then, some other process, a background worker, comes along, picks that job off the list, and does the heavy lifting without the user ever having to wait.
All right, on to our final section. Let's talk about a great problem to have.
Your app is a huge hit, traffic is going through the roof. How do you actually design a system that can handle that kind of success without just falling over?
Well, once a single server isn't enough, you absolutely need a load balancer. Think of it as a traffic cop for your servers. It stands at the front and directs all the incoming requests, spreading them out evenly across a whole group of servers. This is huge because it means no single machine gets overloaded, and it also gives you high availability. If one server goes down, the load balancer just stops sending traffic to it, and your app stays online.
But as soon as you have more than one server, you run headfirst into a fundamental law of distributed systems, the CAP theorem. It basically says that in a network of servers, you can only have 2 out of these 3 guarantees at any given time. Now, partition tolerance, the P, means your system works even if the network connection between servers breaks. In the real world, you can't give that up. So you're left with a tough choice. When that network failure happens, do you choose consistency, where everyone sees the absolute latest data, like a bank, or do you choose availability, where your system always gives a response, even if it's slightly stale, like a social media feed? You can't guarantee both during a failure. It's a fundamental trade-off.
Okay, let's talk about one of the unsung heroes of the backend world, the reverse proxy. The best way to think about it is as a professional middleman. It sits right in front of all your application servers. Users don't talk to your app directly. They talk to the reverse proxy, and the proxy then talks to your app. It's like a receptionist, a security guard, and a traffic manager all rolled into one.
And the reason it's so powerful is that this middleman does a ton of different jobs. It can handle all the complex SSL encryption, it can cache files to speed things up, compress data to save bandwidth, route requests, and even act as your load balancer. By taking all these jobs off your main application's plate, it lets your app servers do what they do best: run your business logic.
And finally, if you want your application to be fast for users all over the world, you need a CDN, a content delivery network. This is a global network of servers that keeps copies of your static files, your images, your videos, really close to your users. So when someone in Tokyo loads your site, they get the images from a server in Japan, not one in New York. It makes a massive difference in load times.
So there you have it. From securing the front door and keeping your data safe, to making things feel instant and scaling to millions of users, these are the concepts that really separate a simple API from a rock-solid backend system. They're the true building blocks of the modern web. The only question left is, which one are you going to dive into next?